The ocean is a powerful force. It can carve coastlines and sink ships. The relentless waves and salty water are a constant threat to maritime vessels. Over time, the sea's corrosive nature can cause significant damage to ships, making it a silent but deadly adversary. But the ocean also has a hidden power: corrosion. Corrosion is like rust. It is a chemical reaction that occurs when metal is exposed to moisture and oxygen. This process can be slow but relentless, gradually weakening the structural integrity of the ship. It eats away at metal, turning strong steel into brittle, flaky rust. This degradation can compromise the safety and functionality of the vessel, making it more susceptible to accidents and failures. For ships, this is a big problem. The hull, which is the main body of the ship, is particularly vulnerable. Rust patches can spread quickly, especially in areas that are constantly exposed to seawater. Corrosion weakens a ship's hull. This weakening can lead to structural failures, making the ship unsafe for navigation. Regular maintenance is crucial to identify and address these issues before they become catastrophic. This can lead to leaks, which can flood compartments and damage cargo. Leaks are not just a nuisance, they can be life-threatening if not promptly repaired, and even make the ship break apart. Corrosion is costly. Ships need expensive repairs. The financial burden of repairing or replacing corroded parts can be immense, affecting the profitability of shipping operations. Sometimes a ship is too damaged and must be scrapped. This is a last resort, but it happens more often than one might think. The loss of a ship is not just a financial blow, but also an environmental concern. This is why we need ways to protect our ships from corrosion. Techniques like anti-corrosion paint and cathodic protection systems are essential. These measures help extend the life of the vessel, ensuring it remains safe and operational for as long as possible. Imagine an invisible shield, a barrier that you can't see but is always there, protecting a ship from the ocean's bite, from the relentless assault of salt water and waves. That's what an ICCP system does. It stands for Impressed Current Cathodic Protection. ICCP is a technology designed to protect the metal parts of a ship from corrosion. It's a mouthful, but its job is simple: stop rust. Here's how it works. The system uses electricity to create a protective layer. The ICCP system uses electricity, which is sent through special anodes attached to the ship's hull. These anodes are crucial. They distribute the electrical current evenly across the hull. This creates a protective bubble around the ship, shielding it from corrosive elements. Think of it like this. The anodes are like magnets, but instead of attracting metal, they attract corrosion. The corrosion is drawn to the anodes, keeping the ship's hull clean and intact. This protects the ship's hull, ensuring it remains strong and durable, ready to face the ocean's challenges. An ICCP system has several important parts. These parts work together to protect the ship's hull from corrosion, ensuring the vessel remains seaworthy and safe for longer periods. Each component has a unique role in this intricate system. First, we have the anodes. These are crucial elements that play a significant role in the system's operation. These are like the system's soldiers. They stand guard, ready to attract and neutralize the corrosive elements that threaten the ship's hull. They are made of a special material that attracts corrosion. This material is designed to corrode instead of the ship's hull, acting as a sacrificial layer. Next, we have the reference electrodes. These components are essential for monitoring the system's effectiveness. These are like the system's sensors. They constantly measure the electrical potential of the hull, providing real-time data. They measure how much protection the hull is getting. This information is crucial for adjusting the system to ensure optimal performance. The control panel is the system's brain. It processes the data from the reference electrodes and makes necessary adjustments. It monitors the sensors and tells the anodes how much electricity to send. This ensures that the anodes are always working at their best to protect the hull. Finally, we have the cables. These are the lifelines of the system, connecting all the components together. They carry the electricity from the control panel to the anodes. Without these cables, the system wouldn't be able to function, making them indispensable for the ICCP system's operation. Like any shield, an ICCP system can weaken. One common problem is damaged anodes. Remember, these are the system's soldiers. If they are broken, they can't protect the ship. Another problem is faulty cables. These are the system's lifelines. If they are cut or corroded, The electricity can't reach the anodes. Sometimes the control panel itself can malfunction. This is like the system's brain shutting down. Without a functioning control panel, the entire system is useless.